All right. With that, I think we are moving on to the next session, which is...
Oh.
Ooh.
Oh, fancy. Okay.
Spotlight.
I know. Here, you go ahead.
Thank you, panelists. Shauna, we're not going to let you off the stage quite yet.
Oh, dang. Okay. No,
Yes, as Andy mentioned earlier, over the course of the day, we're going to be giving our attendees a closer look at each of the DARPA tech offices. So Shauna, if you could please give us a closer look at DARPA I2O, or the Information Innovation Office. Back to you.
Absolutely. And I do information innovation and not IT. Somebody help me. Is this go here? Yes. No? Okay. Cool. You know what? Forget it. All right. Which button do I want to press? The one that goes poof? Boop. Ah, that one. Great. Hello. I'm just going to walk around because I kind of have itchy feet. So again, Shauna Sweet from the Information Innovation Office. And so you guys have already seen this notion of technical thrusts, right? So the Information Innovation Office, a lot of times we like to think about ourselves as software, right? That's actually an insufficient definition, but it's probably pretty good for an overarching way of thinking about the office. And in the office, we have these different technical thrusts. So transformative artificial intelligence, fighting in the information domain, right? Offensive and defensive cyber, and then resilient, adaptable, and secure systems. So what does that mean, right? I kind of made a joke earlier on about LLMs. No, okay. It's a really interesting time to be part of the Information Innovation Office, right? Because one of the things that we're dealing with right now is like AI is not some future. It's here, okay? The integration of probabilistic reasoning into our systems and what that means for the DoD, what that means for national security is really deeply interesting. But what we're looking for in the Information Innovation Office, and also one of my favorite kind of topics, right, is how do we think about not what's today. Don't talk to me about transformer architectures. Don't talk to me about stable diffusion, though I love a good stable diffusion model, right? Talk to me about what is the next thing, right? What is the next innovation with regards to probabilistic reasoning? What are the limits of probabilistic reasoning? What are the impacts of placing that in our systems? Right? How do we think about that? What insights do we need to drive? And I think this was mentioned earlier, I think by Chris, right, where he says in the military, right, we have limited access to compute. How do you think about what it means to do reasoning in situ, in real time, et cetera, right? What are the ways in which we need to push the state of the art in terms of scale, in terms of complexity, et cetera, right? And also we do think about cyber. So we think about access, we think about impact, and how do we kind of navigate the cyber domain, the information domain as well, right? How do we think about not just controlling it per se, but fighting in that? What does that look like? What does that mean? And with resilient, adaptable, and secure systems, right? Open source software is amazing and scary, okay? And also if we think about open source software, and now you think about the introduction of vibe coding, that's neat, right? But what does that mean in terms of the introduction of vulnerabilities and new attack surfaces in our critical infrastructure, in our critical systems, and for the DoD, right? We do want to have the opportunity to have these robust kind of software that is maintained throughout the community. But what does that mean for us, right? And again, as we talk about the integration of AI workflows into coding workflows, how do we potentially leverage not just probabilistic reasoning, but formal mathematics, formal reasoning, right? People talk about formal methods, right? And how do we provide different kinds of evidence and evidentiary guarantees for system behaviors? And so we're looking at how do we layer all those things together, not just to make our systems performant, but to make those systems secure, right? And limiting our attack and vulnerability surfaces. And if you talk to anybody in I2O, you will get some smattering of these things. You will get a cross-cutting kind of intersection of these things. I myself am at the intersection, probably across these thrusts. Oh man, all four. Yeah, all four, right? In terms of the things that I think about, the problems I'm looking to solve. And I think most of my colleagues are the same. And I feel like that was a very fast kind of move through. I will say in the Information Innovation Office, also a lot of the times, a lot of the things that we are looking for in terms of when you come to us and like what you're, so we talked a little bit about this notion of engineering and proof, right? So in other words, show me from first principles that something's possible. Sometimes if we're talking about an extension into the space, we will also be asking you for what is your basis of confidence that this can work? How do you take what's out there right now? And so even though we're talking about software and we're talking about reasoning, we're talking about probabilistic reasoning and extensions, we are also interested in first seeing what's the starting point? Why is what is there today kind of the basis for kind of the leaps that we're going to take next? And it's a really fascinating place to be in I2O, I think. It's one of the reasons I'm so excited about our office, right? Because we sometimes talk about 10 years in the future. What does that mean right now with AI? What does that mean with software? We're probably not, what we think is 10 years from now is probably much closer. And so we are really looking for, right, how do we take innovations across mathematics and computing, and how do we bring those things together to kind of drive us forward for national security? And yeah, that's our office. I feel like I got us back on time. You're welcome.
Yes, you did. Thank you for that. Thank you, Shauna.